Okay, so this is the foundation paper question 2. The diagrams show 3 methods, A, B, and C, used to separate mixtures. Okay, so we've got here a crystallization or an evaporating piece of apparatus. We've got some chromatography, and we've got some filtration. So the questions ask, give letters A, B, or C of the method that you would use to remove sand from seawater. Okay, so that would be method C, because the sand would remain in the filter funnel and the water would pass through the funnel. Okay, so that's C. Show pigments present in different hair dyes. Okay, so that would be method B, chromatography. Okay, so anything to do with pigments is going to be chromatography. And then C, show that seawater contains salt. Then we would use method A, because the seawater here, when you heat it, the water would evaporate off, leaving behind the salt. Okay, so that would be A. And moving along, potassium chloride is one of the salts present in seawater. When potassium chlorate is added, it forms potassium chloride and oxygen. Balance the symbol equation that represents the reaction taking place. Okay, so if we adopt the box method, we've got here KClO3. So that's KClO3. So there's the K, there is the Cl, and here are the O3. And according to the equation, we've got 2 of those. Okay, so we can draw those straight away. So K, Cl, O, O, O. Okay, and then we've got KCl here. We don't know how many we need of these, because we've got a box, but we know that if there's a box there, it's going to be more than 1. And then we've got O2. Okay, so what we need to do is, this side is already finished because the number's present, so we know that this is correct. We just need to make sure we've got the right number of elements on this side to balance. So on this side, we've got 2 Ks, okay, 2 potassiums. And the only place that potassium appears on this side is in the KCl. So there must be another KCl. Now that works out well because we've got 2 Cls here and 2 Cls here. So that means that that's balanced. Okay, so we could put a 2 there to show that. And then the O's, we've got a total of 6 oxygens on this side. We've only got 2 here. So we must need to add an additional 2 O2 molecules. Okay, so that now we have 6 O's altogether that balance the 6 O's on this side, and we need to put a 3 in this box because there are 3 O2 molecules. Okay, part C. The diagram shows the apparatus which can be used to separate a mixture of ethanol and water. Ethanol has a boiling point of 78. Now, it might be useful to know that the boiling point of water is 100 degrees Celsius. It is in fact water on which the Celsius scale is based. Anyway, we've got the mixture of ethanol and water, we've got the Bunsen burner, we've got a little thermometer, and then we've got the Liebig condenser. And you might remember that the Liebig condenser has cold water going in at that end and out at the other, and that cold water surrounds a central pipe which goes down the middle, which allows for gases to enter at this end, and they're condensed into liquids that come out at that end. Right, the following sentences show the steps involved in this method of separation. So A, ethanol boils and evaporates, B, ethanol vapor cools and condenses, C, ethanol is collected, and D, the mixture of water and ethanol is heated. Okay, so put them in the right order. Right, so the first step is going to be step D. Okay, after step D, the ethanol has to boil. Okay, so that's A. Then we've got the ethanol vapor cools and condenses. And then finally, we've got that the ethanol is collected. Okay, so that would summarize the process of distillation.